This lesson is on writing scientific notation. The essential question here is, how can you write numbers in scientific notation? So we're looking at here is the key idea, writing numbers in scientific notation. Step 1, move the decimal point so it is located to the right of the leading non-zero digit. Don't put it by a 0. And step 2 is to count the number of places that you move the decimal point. This indicates the exponent of the power of 10, as shown below. For a number greater than or equal to 10, use positive exponents when you move the decimal point to the left. So if we have 8,600, we're going to move that decimal point 3 places to the left so that it's 8.6. So you've got 8.6 times 10 to the 3. Since the number was bigger than 10, it's a positive exponent. Now for a number between 0 and 1, use a negative exponent when you move the decimal point to the right. So we have 0.0024. I want to move the decimal point until there is one digit that's not a 0 to the left of the decimal. So I'll be moving it 3 spaces, and it'll be 2.4 times 10 to the negative third. An example here is writing large numbers in scientific notation. So example 1 is writing large numbers in scientific notation. Google purchased YouTube for $1,650,000,000,000. Write this number in scientific notation. So what you're going to do is you're going to be moving the decimal point 9 places to the left, because you want one digit to the left of the decimal, one non-zero digit. So you're going to have 1.65 times 10 to the 9th because we moved it 9 places, and it's going to be positive because the number is greater than 10. So let's look at example 2, writing small numbers in scientific notation. In 2004, Indonesian earthquake slowed the rotation of Earth, making the length of day 0.0000268 seconds shorter. Write this number in scientific notation. To write this in scientific notation, we're going to have to move the decimal point 6 places to the right so that we get, remember, we want a non-zero digit, so it's 2.68 times 10 to the 6th, but it's going to be negative because this number is less than 1. So it's going to be 2.68 times 10 to the negative 6 because it is a small number. For example 3 here, we're going to use scientific notation. An album has sold 8,780,000 copies. How many more copies does it need to sell to receive an award? I know you can't see on this screen, but on your paper you probably can see a little better. An album receives an award when it sells 10 million copies. So how many more do I need to get to 10 million? So we're going to use the model to solve the problem. Remaining sales needed for award equals the sales required for award minus the current sales total. So our sales required is 10 million minus what we've already got, our current sales, which is 8,780,000. When we subtract those, we end up with 1,220,000. And if we're going to write that in scientific notation, remember we want one digit to the left of the decimal, so we're going to get 1.22 times 10 to the 6th. We're moving the decimal point 6 places, and it's a number bigger than 10, so it's going to be a positive exponent. So the album must sell 1.22 times 10 to the 6th more copies to receive the award. So the correct answer is C. Now for a real-life example here, we can use a real-life application. The table shows when the last 3 geological eras began. Order the eras from earliest to the most recent. So we are going to look at the Paleozoic, the Cenozoic, and the Mesozoic. First, you need to compare the powers of 10. Because 10 to the 7th is less than 10 to the 8th, we know that 6.55 times 10 to the 7th is less than 5.42 times 10 to the 8th. And 6.55 times 10 to the 7th is less than 2.5 times 10 to the 8th. So now you need to compare the factors when the powers of 10 are the same. So we're going to be looking at the 2.51 and the 5.42. Since 2.51 is less than 5.42, then 2.51 times 10 to the 8th is less than 5.42 times 10 to the 8th. So if we're going from greatest to least, the order would be the 5.42 times 10 to the 8th, which is the Paleozoic. Then it would be 2.51 times 10 to the 8th, which is the Mesozoic. And then 6.55 times 10 to the 7th, which is the Cenozoic. So the eras in order from earliest to the most recent are Paleozoic era, Mesozoic era, and Cenozoic era. Make sure you finish the problems at the end of the notes, bring up your notes for me to check, and then work on your assignment on Clever.